Now, there are going to be some graphs that you need to know. My concern is that do you know where they come from? Okay. Now, last time I checked, you all have finished Algebra 2. You all know what is linear equation, right? You know y is going to mx plus b. Okay. All right. So we'll get to that in a moment. But first, let's talk about reaction rate. That is something brand new. You did not learn this in Chem 1, and you need to really understand what the heck it is. Reaction rate, in other words, is like speed. How fast of a reaction? Now, there are three types of reaction rate that we're going to see. And to do that, I would need to draw three pairs of axes. Okay? Three pairs of axes. And for this simple generic equation, it's going to be one, A is a reactant, and A will become B. Okay? A will become B. Good? All right? So, now, the three types of reactions right here, they have very simple names. They are known as zero order, first order, and second order. Okay? All right? All right. What's a zero order? The meaning of zero order reaction is this. It means this. The rate is not affected by the concentration of reactants. Now, when I see you next Tuesday, I would ask you to draw all these graphs first before we start, because if not, you are in a very dangerous zone. Okay, so again, zero order reaction means the rate is not affected by the concentration of the reactant. So what does it mean graphically? What does it mean graphically? It means something very straightforward. It's a straight line. It's a straight line. Okay? Now for, I think we have 3 calculus students. Oh no, Emma, you finished calculus already? So 3 calculus ready student, okay? Slope, it's constant. Okay? If I ask you to write an equation for this, well, as I said, y is equal to mx plus b. Y, it's equal to. Now, with the m, now it is negative, right? So the slope, it's going to be negative k. And then your x, it's your time, so we put t plus the initial concentration of the reactant. So first, can you see how this equation right here resembles y it's equal to mx plus b? I would talk more about k later, but can you see how you have y, you have slope, you have the t value, and you have your y-intercept? Are we good? Yes? Yes? All right. So that's very straightforward. That's zero order. What about first order? First order is when the rate will be influenced by the concentration of A. Okay? Directly, Yeah, I'm going to elaborate on this directly, okay, in a moment. I don't know what's the best word to describe it here, but let's just use the word directly. So what kind of graph are we expecting? Well, it won't be a linear line because a linear line means that if your concentration drops, the rate stays the same. So what it means directly is that when the concentration drops, the rate shall decrease accordingly. So for calculus students or calculus ready students, you know about F prime, right? The instantaneous rate of change. So that makes a lot more sense. For non-calculus student, you should have heard about instantaneous rate of change, right? Like what's the instantaneous rate of change of this point? You just go ahead and draw a little tangent line. Okay, so what we're saying here is that, yeah, go ahead, compare the slope. Can you see the slope getting flatter and flatter as the concentration drops? Okay, so it's like you are having fewer workers at a factory, so the production, the manufacturing, it's going to be less. Well, it's not. It's not a linear line, so we cannot write an equation for this line. But there's one concept that I would like to make sure that you have. It's called linearization. How can I subject the data from this graph to make a linear line? How? Well, first, you need to understand a couple of things. What kind of data is this? Well, that's not linear. That looks like an exponential function reflected. And if you want to create a linear line, then you need to do the inverse of exponential, which is, what's the inverse of exponential function? Log. So that's why we will do natural log of the concentration of the concentration. And when you have it, it will become a straight line. It will become a straight line. Now, let me share something with you. When I was doing this unit, back then, I was doing it all by myself because I joined AP Chemistry after this unit, and I had zero idea what these equations are, like the one I'm about to write down. And this is the reason why I need you to know the backstory. Because a lot of students who do not understand the backstory, they would not even know that this graph would transition to this graph for this very reason. So what's the linear equation? Y is equal to m. So the m right here, the slope, is still negative k. The x is still time, plus natural log of initial reaction concentration. Okay? Initial reaction concentration. So that's what I mean by directly. Okay, so you will see more examples later on. So when we say, hey, what do we mean by first order? It means that if your concentration drops by half, your rate would also drop by half. Okay, if your concentration drops to 1/3 of the original, then the rate would also drop to 1/3 of the original. That's what I mean by directly. Now, what about second order? Well, it's practically the same thing, except that it is not just directly. but it's in quadratic. So you may now understand why we call first order and second order. That's basically the power. So what does it mean? If the reactant concentration drops by a half of the drop to the a half of original, then the rate would only become a quarter of the original. And the resulting graph, it's going to be like this. Oh, sorry. Let me draw it better. Okay. So what kind of graph does it resemble? It resembles y equals to 1 over x, like this. Okay. So if you want to make a straight line out of this graph, what must you do? You do the inverse of 1 over x, which happens to be also 1 over x. Okay. But since it's being reciprocated, the graph would have a positive slope, right? When you divide by a small number, by 1 divided by a small number, you have a bigger number. So what is the equation right here? Y is equal to mx plus b. Okay, so I want to just show you these simple graphs, and I would also like to tell you something. I will tell you what not to do. Okay, so what are something that you should not do? You should not just memorize these graphs and these equations without knowing the backstory. You should not do that. Okay? You should always understand that these are the 3 original graphs, and since we want to have some linear lines, because we like to work with linear lines, so we have to inverse the function, or we linearize the function to have these 2 graphs as a result. When you try to get your equations, you don't have to just force yourself to memorize these 3, because these 3 are just y is equal to mx plus b. And again, I will tell you more about the k in just a moment, but it's just y is equal to mx plus b. If you know how to construct those 3 or these 3 linear graphs with the axes labeled, there is no doubt you will get these 3 equations. Okay? All right? Good. Now, got a sad news though. Well, not very sad, but it is sad. AP Chemistry reference sheet. Let me go ahead and show it to you right here. Now, are these equations given? Yes. Yes, actually on the AP exam, but they are presented in this way. I mean, they're the same thing, it's just being rearranged. But you will not be able to see like, oh, that's a linear equation. Okay, we're talking about the same thing. All right, if you add all these little terms back to the right hand side, we have the same exact equation. Good. All right. So now, if you're good, I will now go ahead and show you something. All right, something easy. Something easy first. All right, something easy. Something easy. Ready? Ready? If I show you this graph, Can you tell me what order it is for the reaction? 0, first, or second? First. How do you know it's the first? Natural log. And it has a straight line. Okay? Now, how about this? If I show you all three graphs, okay? If I show you all three graphs, what order is this particular reaction? Like if you, like now, the reason why we have three graphs is because we have some data points right here, and we just subject the data points by saying, hey, let's go do 1 over. Let's go do natural log of the concentration. So that's how we produce all three graphs. So can you tell what order it is? Second order. Why? It is a straight line for this particular graph. It is not a straight line for the other two graphs. That's the reason. Okay? So when the reaction has a second order, this would always be a straight line. And that's why you need to know how to draw the graph. You need to know the backstory of the graph so that you understand, like, oh, that's why first order reaction is a straight line when natural log of the reactant concentration versus time is linear. It is a second order reaction when, or 1 over the concentration of a reactant versus time, it's a linear line. Okay? So that's the key of like visually recognizing the order of a reaction. Are we good? Yes? Now, if you're good, I just got one more thing to add for these three equations. Now, we will do some calculations with these. No rush. But what I want you to acknowledge first, it's a name. These three equations are known as the integrated rate law. Okay, integrated rate law. Now, the name actually, in this case, it's not that impactful. What is impactful is your recognition that all these three equations got a variable time in it. If you have some calculation and it involves time, it's a very strong indicator that this is the direction of your path. If your calculation does not involve time, don't worry about these three equations. It's not.